Did you guys win? You got superior. You got the best.
It's not a competition, it's an adjudication.
What's that?
That means you just get rated.
So they got ranked in the top rank. So it's kind of.
So it's like our levels of measurement that you have. There was just a ranking that's there, but there's no value that's a separation value between this value to this value.
Wait, how many people got superiors? Three. Who was?
So that's there's no quantitative values there. There's only just qualitative values that go with it. So that's the level of measurement we talked about. All right, on Wednesday, hope you enjoyed your day off. We started talking about measures of variation. We talked about measures of variation. Okay, we have two sets of test scores that a student had. But with those test scores, one's more spread out, one is more consistent. But both of these students got the same grade. They both got an 88. Their central tendency value was a value of 88. If we take a look at this, what would be a truer indication? Or would the mean or the median be a truer indication in regards to their test scores? Okay. But we started talking about the consistency and things that are being spread out. And this is a measure of variation or a measure of dispersion. It basically measures the spread of the data. Are they closely packed together or are they spread out? One way of doing that is the range of values, your largest value minus your smallest value. But then the second one is the idea of a variance and the standard deviation. The variance is the average of the squares of the distance between the values and the mean. And we set up a table with here's our values, here's our value minus the mean, here's our value minus the mean squared. We added down the column. The mean or the standard or the variance is calculated by the sum of these values squared divided by the total number of values. It's the average number or the average distance squared the distance between the mean and the actual values. We then start talking about the standard deviation. Standard deviation is a little bit more practical with respect to mathematics. The standard deviation is the square root of our variance. And this is a relative concept in regards to the bigger the standard deviation, the more spread out the data is. The smaller the standard deviation, the more compact or more consistent the values are. We then took a look at a grading scale. When we were looking at a grading scale, what happens with respect to a grading scale, grading on the curve. And that's basically where we left off. When we have a sample, when we look at a sample rather than a population, to calculate the sample variance, we use S. S is our sample variance, where sigma is our population variance. But when we're dealing with a sample variance, we're going to divide by the sample size minus 1. So we divide by n minus 1. Sample standard deviation is still the square root of that. When we deal with the group data, this becomes a little bit more complicated to be able to handle the group data. Look back in our notes. What was our mean for, when we did central tendency? This is the exact same set of data values. Was it 24.8? That would have been what we did the previous day with the central tendency, the mean. I think we came down to 24.8. Yep. All right. So our mean was here, 24.8. When we have group data, we want to still be able to calculate a standard deviation, the variance in the standard deviation. It's a little bit more complicated, but we can still get through it. We still look at our midpoints. Our midpoint values, let's see if we looked at our midpoints. This was 9.5, 19.5, 29.5, and 39.5. That's the midpoint between our values there. Okay, we look at our midpoint. Okay, now how we calculate our variance, we went value minus mean and then we squared it. We went value minus mean and squared that. Well, we don't have a value anymore, but we have a midpoint minus our mean that we can square. So we have our midpoint minus our mean, then we're going to square that. And then since we have 2 in these categories, we're going to multiply it by 2 because we're going to have 2 of whatever values we have. So we have the 9.5 minus the 24.5 or 24.8. We subtract that out. So when we subtract that, what do we come up with? 9.5 minus 24.8. Negative 15.3. Now we can just hit our square button. That will pull down my answer and square it. So when we square that, what do we come up with? 234 point what? 234.1. And then we can just multiply by our frequency. So we can just hit our times button, our multiplication button, and multiply that by 2. So once again, we're going to work across our table, then down our table. So we multiply this by 2. Multiplying by the frequency, we get 468.2. So go ahead and do the rest of our values there. Value, our midpoint minus our mean. Then you square it. Then you multiply by the frequency. Just work yourself across each row and then down to the next row. Once again, mathematically, it's not an ooh and ah type of thing, but it's just something different that you're dealing, or you're working with different things and getting a different meaning with respect to the mathematics. All we're doing is we're subtracting, we're squaring, and we're multiplying here, then we're adding. So we're not doing anything major here mathematically. Hopefully I did them correctly. Looks like we got the same. Okay, so when we calculate our variance, We do the sum of our values. We have a total of 15 values here, but since we are group data, this is probably going to be a sample. So when we have a sample, we divide by our n minus 1. So let's add down our column out here. Find the sum of these values as we add down the column. Then we have 15 minus 1, or we divide by 14. That gives us our variance. And then we can take the square root of that to get our standard deviation. Abby, what do you get for the variance? 98.1, and then was 9.9. So that is our spread of our data values. And if we take a look, we're right around 10, and we're fairly balanced here. And bless you. And the difference between our values is a value of 10 there. The size of our class is about a 10, so they sort of correspond with each other. Once again, mathematically, nothing difficult. It's just something brand new. The empirical rule. When we deal with the empirical rule, we have a normal distribution, which is a bell-shaped curve. When we talk about a bell-shaped curve or normal distribution, you're looking at a distribution that is, we have big in the middle, and then we fade off fairly the same on both sides. So this is what is called a normal bell-shaped curve or a normal distribution. Okay, it's a type of distribution we were talking about before. Statistically, and this is what a lot of statistics deal with in regards to when calculating out and projecting out, if our data is fairly normal with a bell-shaped curve, 68% of the data will lie within one standard deviation of the mean. One standard deviation of the mean. Now, what do we mean by that? Well, suppose we have a mean of 71, and we have a standard deviation of a value of 8. The mean value of 71 is going right here. The mean, the median, mode are all going to be in the same. Now, if we take our mean and add one standard deviation, and our mean and subtract the one standard deviation, we have 71 minus 8 and 71 plus 8. So we are at 79 and 63. if we look at our histogram here and look at these data values, what the empirical rule states is if I look and count up the percent of the data values that are basically between 63 and 79. Between 63 and 79, 68% of the data, 68% of the data values will be between the values of 63 and 79. What this is utilized for is to make predictions. I have a 68% chance. If I have a quiz score, we talked about grading on a curve. I have a 68% chance of scoring between a 63 and a 79. Because 68% of the data values are between those two values. 95% of this data values will lie within 2 standard deviations of the mean. So if I would take my x bar and add 2 standard deviations, or x bar and subtract 2 standard deviations, we have 71 minus 16, or 71 plus 16. We are left with the values of 87 and 55. What the empirical rule states is that between these values here, between 55 and 87, %95 of the data values will lie between the values of 55 and 87. So you have a 95% chance of scoring between 55 and 87. And the last one is 99.7% of the data. So we have x bar minus 3 standard deviations and x bar plus 3 standard deviations. So we have 71 minus 24 and 71 plus 24. So we have 95 here and 47 here. 99.7%, but basically all the data values. Between those two scores, 99.7% of the data values, which means you probably have one data value that's going to lie outside of that. 99% of the data will lie within 3 standard deviations of the mean. This is what they use in regards to predicting out. These are the ideas that they use. There's a lot of different things that we do with this normal bell-shaped curve with the z-scores and things of that sort that will actually give us percent values that are going to be between this value and this value. But it all reverts back to the empirical rule about the data values. Now I know what we do is we split, when we are grading on a curve, we split one of those values up. This is only half a standard deviation, half a standard deviation here. But when you are grading on the curve, the bulk of your scores lie there as C's. And what you have is you have a histogram that looks like this. And then we start trickling off. And you have fewer and fewer as you go out. So the bulk of your scores when grading on the curve is centered around a C value. Less percentages are going to be B's and D's, and fewer percentages are going to be less or A's and F's. But the bulk of your scores are going to be right in here. Once again, that is grading on the curve. Questions about standard deviation and variance? Okay, what I ask you to do is you're supposed to start on a worksheet. You will be able to complete the worksheet now in regards to your standard deviations. Okay, so the worksheet I handed out on Friday or on Wednesday, you were able to do the front half with what we did. You should be able to go to the back half now and do the work on the back side of the worksheet. Questions you have? Okay, you have about 15 minutes, so you should, if you only have to do those last couple problems, you should be able to get it completed here within the class. If you have to do the front still, okay, you're probably not going to get everything done here in the class, but whatever you did not get accomplished for today, accomplish that for Monday. Questions? You check your answers? No. And those are things, once again, all my worksheets is when you have it's like the worksheets I had in class. Things aren't going to get turned in. How I will grade you on that is have an in-class assignment, which you'll be able to utilize all your notes on. So that's how I grade in regards to work that you completed. What this is your practice in regards to any type of evaluations. You have to get used and practice the skill that we're dealing with here. So this is the usage that you can in regards to practicing that. Yeah. I'll have something next week. I don't know when it'll be. I don't know when it'll be. I'm not quite sure yet. I have to think through the process here because everything got boogered up this week. So we'll start getting some in-class assignments and things like that